Hello everybody, I will start my today's another coding practice. So in this video, I will solve a question, find first and last position of element in sorted array. Okay, so in this question, I will be given an array of integer nums sorted in non-decreasing order. Find the starting and ending position of a given target value. If target value is not found in the array, return -1, -1. You must write an algorithm with O of log n runtime complexity. I see. So when my target value is 8, I will return the first position of 8 in the sorted list. And also, I will find the last element, last 8 in the sorted list. Then I will return the range of that. So, I will return the tuple of those indexes. And if the target value doesn't exist in the list, I will return -1, -1. Okay, I've understood. So, firstly, I could understand this question. Everything is clear to me at this moment. So, let me get started to the implementation. Okay. No, sorry. Let me think of the algorithm. What I can do. So as a brute force approach, simply I can iterate all the elements in the number list. And in this case, I will take a look and I find the first 8 at position 3. And then I find last 8 at position 4. I will find it after moving the pointer to 10, actually. But in that way, I can return 3, 4 tuple. So that's the brute force approach. But I'm expected to solve this question in the overlog n time, so I will think of the better approach. So probably I can use the binary search. So when I'm looking for 8, obviously I will think of the middle number of 5 and 10, which is 7.5. So say I will take a look at 8. Then, because 8 is the number I'm looking for, yeah, this can be the start. Yeah. So in that way, obviously, I can find the target number in the log n time with the binary search. Then I can also, I will look for the target 8 in the last position. I mean, last 8. Yeah, so I will do some, customization on the binary search, and I can find both the first element 8 and last 8 index. Then I will return those tuples. Okay, so let me implement that. And also, one more thing I try to tell you is I actually can use Python's standard library bisect. So that's one of the approach I can take. Okay, so in this video, I will firstly quickly implement it with the bisect, and then I will implement the binary search by myself without using the bisect. Okay, so in the first approach, I will use the bisect. So basically, so I can use the bisect in this way. So let me tell you how this solution works. So in the bisect Python library, what I will try to find is index whose number element is larger than the given target number. So let me tell you. So in this case, if I'm given 8 with bisect left, I will try to find the number which is equal to larger than 8, which is the target. Then I will return the smallest index. So in this case, this one is the mini index. However, if the element is not found, what happens is the element which is larger than the target and the leftmost index, the leftmost one, that index is returned. So that's why I had to check if the mini index number is really target or not in line 13. And also, I have to make sure that if target is much larger than quite large, larger than the last element in the nums, which means that all the numbers in the nums are smaller than the target or equal. In that case, this returns the actual length of the nums, so in this case 4. So in that case, in line 13, this portion, nums mini index, will be out of index. So that's why I checked it in the first half of line 13. And in line 17, I used bisect right. So bisect right, oh, sorry, this is wrong. I can use bisect left again. So with this, I will try to find the number. Okay. Oh, sorry. I think I can use bisect right, and I don't need to decrement by 1. Like this. In this way, bisect right, I will find the number the Redmi. Oh no. So I have to do this. With bisect right, if target is 8, I will find the index, first index, which is larger than the target. In this case, this 10 is the index. So I have to decrement by 1. Subtract 1 from that index to get the final, get the target index. And also because I confirmed that the number exists, this max index is always in the valid range, and it is guaranteed that this number is the target number. Okay, then let me execute my code. Good, accepted, subtract. Okay, now it's accepted. So from here, I will implement the binary search by myself. So I will use the helper method. I will implement those sub-methods. Okay, so for the first index method, in the binary search, I will try to use the two variables, low index and high index, which represents the range. And I will try to take a look at the middle number, which is at the center of the low and high index. Then I will see if that number is smaller than smaller than the target. I can say the number I'm looking for is at the right hand side, larger side. And if the middle number is smaller, the target should be on the left hand side. And if the center number, middle number is exactly the target number, then I can say the first target number should be that one or smaller as a smaller index. Smaller half. So that's the main idea, and I will try to iterate this process until the range is exactly only one number. And still, if I can't find the target, I will return -1. That's it. Okay, so let me implement it. Let me run this to just target. So if the number is okay, so if the target is 8, and if the middle number is say 7, I can say the low index should be middle plus 1. Otherwise, if I find 8, let me say, I can say this is the index I'm looking for, first 8, or this is first 8 is, in this case, on the left hand side. So I can say high is middle. Yeah. Then otherwise, this is the case when target is smaller than the middle number. Middle number is larger than the target. So like this, if I find 10, I can say high index is middle -1 because it's on the smaller side. Then I will continue it. And up to this iteration, now low is high. And I will check if this is the target, then I will return low. Otherwise, I will return -1. Okay. One thing I need to take care is so I just want to take care if this is say 3 and 4, low plus high divided by 2 should be 3. I want to confirm this while loop wouldn't go into the infinite loop. So in that case, I'm taking care of the case when high is rho plus 1, and after that, that condition, high is rho plus 1, continues forever. I need to check if this narrowed down the scope, even in that case. So if high is rho plus 1, the middle should be rho 3, and in line 23, low becomes 4, so the range is narrowed down, and in line 25, high is middle. So it's still narrowed down, and high is middle minus 1. Yes, it narrowed down. Okay. So it's okay. So yeah. But in that case, yeah, okay. Low is equal to high is not necessarily true. So I will remove this condition. Okay. Yep. And now I will implement Rust index. Basically, I can use the similar technique. However, only thing it makes a difference is if the target number is found as the middle number, the low index should be, the last target number should be this position, middle position, or later. So in line 44, I use low is middle. So that's the thing. And if I do that, something which was afraid happens. So if 3, 4, high is 4 and mid low is 3, it becomes the infinite loop. Yeah. So I try to do it in this way. So if this happens, I would like to choose the middle as 4. In that way, this will never go into the infinite loop. Yeah. Okay. So how I can do it? So probably I can do low plus high plus 1 divided by 2. So this is the way I can avoid the problem. Or I think I can use plus 1 here. I think this is more, maybe just a little bit easier to understand and calculate. I will use it. Okay. Good. So wait, if I do that, low plus high divided by 2 can be, if low is 3 and high is 5, it should be 5. So middle is equal to high. Yeah, so I think, let me do it in this way. So in that way, yeah, if low is 3 and high is 5, the middle should be, yeah, still 4. Okay. Exit my code. And I need to comment out the first approach. Oh. I see. I see. So it can go out of the range of the nums. So in that case, I have to return -1. So I would say if in this case, there's no limit. There's no number possible. So let me, okay. So let me say in this way. So if low is equal to high, and also nums low is equal to nums high. So no, what I'm saying. So if low is equal to high, which means that the target number is found. And in that case, I will return low. Otherwise, I will return it to 1. Yeah, so that's the thing I should do. Okay, if low is equal to high, it is guaranteed that the target num target is found in the range, and also it is guaranteed that this row and high is in the possible range. Obviously, I will return low index. And seems like last index is wrong. Wait. Oh, I think this should be is equal. Yeah, I was talking in that way. Sorry. Okay, so now let me think. If this is 6. Oh, I see. So I have to make sure that num's row is equals to num's high here. I mean, sorry, num's row is equal to target. So this suggests that low is equal to high. In that case, still, that number cannot be the target. Obviously, this is the case when target is, say, 5, and the given array is only 4, only a single element. In that case, low is 0, high is 0, so it doesn't go into this while loop and go to this line 29. So yeah, that's a problem. I see. Okay, so that's it. Okay, I will submit my code. Good, now it's accepted. Okay, so in this question, let me wrap up. So in this question, I implemented the binary search, basically. So my task was to find the index whose element is equal to the target and the first index out of those indexes. And also I had to find the last index whose number is exactly the target. And firstly, I implemented those with this, bisect library in Python. And after that, I implemented it without bisect library. So I used the kind of 2 pointers approach, which narrowed down the scope of the target can exist. In that way, yeah, I could implement it. Okay, thank you so much. I finished my today's coding practice with this.